This is AP Physics B FRQ question from 1983. And now these topics are covered in AP Physics 2. They used to be AP Physics B. So I found this question and I wanted to go over it with you. So in this question, they say that the current shown above is constructed with 2 batteries and 3 resistors. The connecting wires may be considered to have negligible resistance, and the current I is 2 amperes. And then calculate the resistance R. So if we have 2 batteries connected in opposite direction, so you have the positive side of the battery here and the negative side on the other side, and then again the positive on the right side and the negative on the left side. So they are opposing each other, they are not connected in the same direction. So their total EMF is going to be the difference between them. So the EMF of this circuit is going to be the difference between 2, which is 18 volts. And to calculate the resistance R, we need to know the total resistance in the circuit. So I have the resistance R right here, and then I have 2 resistors in parallel, 12 ohm resistor and 6 ohm resistor. There is a formula to calculate the resistance, the total resistance of parallel connection of the resistors. And the formula says it will be 1 over R1 plus 1 over R2, and then you have 1 over R total. And I use a different way to do this in my classrooms with the students. What we say is 1 over plus 1 over, the result flip over. So what that means, 1 over the first resistance, which is 12, plus 1 over the second resistance, which is 6. The total, the common denominator is 12. So I would have to times the second fraction by 2 in the numerator and denominator, and I would get a 3 in the numerator. So my result would be 3 over 12. But the way we say it is 1 over, your result flip over. So the total resistance in this case is 4 ohm. So I could replace these 2 resistors with 1 resistor of 4 ohm. Then I will have 2 resistors in series. So my circuit is going to look like this. I have resistor R, the one that I have to find the resistance. I could rewrite the battery like this with 18 volt instead of the 2 batteries. Then I would have the resistor that I just calculated, 4 ohm, the total resistance of those 2 parallel, and then my circuit is going to be complete. The current always flows from the positive side of the battery to the negative side of the battery, so the current is shown, it is in this direction, and it is 2 amps. If I want to calculate the resistance of this resistor, I'm going to use Ohm's law. So V is equal to I times R. Now these 2 resistors connected in series, so in order to find their total resistance, you just have to add them. So I could rewrite it this way. The voltage, which is 18, is equal to the current, which is given 2, and the total resistance is the sum of 2 resistors. So it's R plus 4, the one that we found 2 for those parallel. So if I solve this equation, 18 is equal to 2 times R plus 4, something times R plus 4 is equal 18. So if I divide this by 2 both sides, then that something must be equal to 9. So R plus 4 is equal to 9. And from here, I can see that R is equal to 5 ohm. So that answers our first question. R is 5 ohm. I cleaned a little bit my screen. So you have this resistor R, you have 12 ohm resistor, you have 6 ohm resistor. The total resistance of those 2 is 4 ohm. I wrote it inside. And for the next question, they ask, calculate the current in 6 ohm resistor. So at first, I know how much the voltage is in the battery. So I'm going to rewrite it again. So these 2 resistors, maybe I'll just color them in red right here. These 2 resistors if I calculate the total resistance, we said their total resistance was 4 ohm. And then the one that we calculate right here is 5 ohm. And the EMF of the battery, when we subtracted them, we said that one was equal to 18 volt. So when we do this in the classroom, I always tell the students to look at the voltage as if it was something that you have in your pocket when you leave the house. So you have 18 volts in your pocket, like money-wise. So when you leave in the house and you're going to go from positive to negative direction, so you're going to be traveling this way. And I'm going to call you as an alien because current is measured in amps. So some alien is traveling this way. This alien will pass through this bridge or room, and every time he passes through the bridge or room, he has to pay. So he has to give some of the money that he had in his pocket when he passes that bridge. So if you had 18 volt in your pocket, to calculate how much voltage you give on the first resistor, that would be the Ohm's law, which is I times R. The current is given to be 2 amps. So you have 2 times 5. That gives you 10 volts. So the voltage is always measured parallel to the resistor. So the voltage right here would be 10 volts. And then the total voltage is 18. So if you lost 10 volt on the first resistor, you will have to lose the rest of it on this resistor, on 4 ohm resistor. So right there, you would have to lose 8 volt because the total must be 18 because that's how much you had when you left the battery. So when they ask you the question, calculate the current in 6 ohm resistor, what I do know is the voltage between the points C and D. So the voltage between C and D is 8 volts from over there. And the current is equal to the voltage divided by the resistance. So if I'm looking for the current through 6 ohm resistor, then I have the voltage, which is 8, divided by resistance, which is 6. And that will give me 4/3 or 1.33 amps. So what this means is when the current is flowing this way, there's 2 amps floating through this line. And then by the time they get to this point, D, they have to split. And so if there's 2 aliens are coming, and aliens are not like people, you don't have to split them evenly when you split them evenly. So my students enjoy this conversation sometimes. So what I have here, I can split my currents not evenly. 1.33 of them is going to go here, and the rest is going to go that way. So that means 0.67 of them is going to go through the other line. And when they meet right here, the same 2 aliens will come back to the home where they left to the battery. So when they ask you how much current is flowing through 6 ohm resistor, that one gives us 4/3 of an amp, and the other one is going to be left wherever that is from 2 amps. So if you subtract 4/3 from 2, you get 2/3 of an amp floating through the other resistor. And then for the last question, they ask the potential at point X is 0 volt. So here is the potential at X is 0 volt. And then calculate the electric potential at point B. And here is point B. So when you're calculating the potential difference between B and X, it's the same as calculating the potential difference between, or the drop of the potential difference on the 5 ohm resistor that we did a little bit earlier. So you're finding the voltage drop between 2 sides of the resistor R, this one. And then we found that to be 10. So this would be 10 volt. And then for the second part of this question, they ask you to calculate the voltage on points C and D of the circuit. I'm going to use Kirchhoff's law to explain this part. So for Kirchhoff's law, what you do, you lose the, and I'm going to replace this resistor with one big resistor. I'm going to use the rectangle for this big resistor, and we calculated that the resistor was 4 ohm. And then the current is given 2 amps. So if the current is 2 amps and it's flowing in this direction, that means this side is going to have more positive charges than this one, because the current is flowing from positive to negative, so right here. And then this one is negative. And then again, this one is positive side, this one is negative. If the current is flowing this way through those two resistors, then this side is going to be more positive, this one is going to be more negative. Now, the next thing I have to do is to choose the direction of the loop that I'm going to be following. And I'm going to choose the direction of the loop. It's up to you which direction you're going to choose. I'm going to choose my direction of the loop is this way. In Kirchhoff's law, there's two Kirchhoff's law. One is the current law and the other one is the voltage law. And the current law says that if there is a node, the sum of the currents that coming in, so let's say these 3 currents are coming in and 2 are coming out. So the sum of these 3 currents that coming in must be equal to the sum of those 2 currents that coming out. So that would be the first current law for Kirchhoff's law. And then the second one says, if you have a battery and you go all around the loop, so let's say we had 18 volt of battery and we went all around the loop and we had one resistor, the other resistor, we lost 10 volt here, we lost 8 volt here. So if you go all around the loop, the sum of the voltage that is going to be left at the end is going to be equal to 0. So all the voltage that is lost within the circuit must be added and must be equal to 0. So now I'm going to follow this rule through every single point. So when I pass following this loop in this direction, so when I follow it in this direction, my loop, I'm going to copy the sign that I see as soon as I pass the element. So when I pass 20 volt element, I see a positive sign. So I'm going to write positive 20. So that's the first voltage. Then I'm going to pass this resistor. And when I pass the resistor, I see the sign negative. So I'm going to say minus, and I have to write the voltage. And the voltage on that resistor was 10 volt, or it is the resistance times the current through it. Then I'm going to follow again this line in this direction. By the time I get to this battery, again, I pass the battery and I copy my sign. So that is negative. So I'm going to write negative 2. And then I'm going to follow in this, I combine those two resistors together. It's 4 ohm. So when I pass that resistor, I see a sign negative. So I'm going to say negative. And then the resistance, which is 4, the total resistance of those two, times the current. And that must be equal to 0. And if you add these two, so you have all of these, you have negative 20, and then you have negative 10, and then you have negative 2, and then you have negative 8, all of that will give you 0. So that is Kirchhoff's law about the voltage drop in the loop. And I'm going to use this Kirchhoff's law to explain what's the potential difference between point X and point C. So here is point C. And what's the potential difference between point X and point D. So when I move in this direction between point X and C, if I move in this direction of the loop, then the voltage drop here is 10 volt. And I'm going to copy the sign positive when I move up, right? So I have a positive. And when I pass my voltage, I'm going to copy the sign negative, so negative 20. So the potential difference between point X and point C is negative 10. So that's going to be negative 10, the sum of those two. And then if I move in the opposite direction, this way for the second battery to point D, from X to point D, then as soon as I pass the 2 volt battery, I see a negative sign, so the potential difference between point X and point D is going to be negative 2 volts. So that answers this question. And then the last one, they ask you, calculate the power supplied by the 20-volt battery. And the power has a formula. It's I times V. And I have the current through the 20-volt battery. It's the same current going through the whole circuit, which is 2 amps. So the current is 2 and the voltage is 20. So the power is 40 watts. So the last question for D, calculate the power supplied by the 20-volt battery, would be 40 watts. And that is all I have for this 1983 AP Physics B FRQ question. And thank you for watching. If you enjoyed it and if you learned something, subscribe. And I hope I see you in my future videos.